Assalamu alaikum. Good afternoon, everybody. So today we are going to discuss about the pre-board first year full paper mock exams, and we are going to discuss the MCQs portion first of all. I'll try to discuss all the 17 MCQs here. So the first MCQ is about electrometer. So electrometer is also called. This is present in topic 13.2, and you can see the line highlighted over here that electrometer is also called ion collector. So ion collector is the right answer for this question. One more thing you need to understand is that voltmeter is actually used for measuring the potential difference, and galvanometer is used for measuring the electrical current. Avometer is known as multimeter, but these all three gadgets can be used for the current already passing. Ion collector is a type of detector. It is a detector used in mass spectrometry. Okay, so ion collector is that part on the machine on which when the isotopes with different masses fall, they will generate an electrical current. Okay, so electrometer is actually the ion collector. Now, the second MCQ is about the volume occupied by 1.4 grams of nitrogen at standard temperature and pressure. Now, we have to see the standard first of all. We'll make 1 mole of nitrogen. For 1 mole of nitrogen, we know that the atomic mass of nitrogen is 14 and we have two nitrogens. So overall we have 28. This one is known as molecular mass. The students who are from the background of O levels write it as MR or molecular mass whatsoever, you can use it. So 28. According to the standard, at standard temperature and pressure, 28 grams of nitrogen means 1 mole of nitrogen contains a volume of 22.414 decimeter cube. This is written in your book. So if we have 1.4 grams of nitrogen, then what will be the volume? I'm writing X here. So just cross multiply the two and you'll get your answer. So I can write it here as X is equals to, okay, let me solve this whole. X multiplied by 28, that will be equals to 1.4 multiplied by 22.414. So X will be equals to 1.4 multiplied by 22.414 decimeter cube divided by 28. The answer is 1.12. You can calculate this answer as well, but the method is same. You will get it here. X is equals to 1.12 decimeter cube. Okay, that's your answer. So it's a very simple way to solve this question. Now, the third question is about the sublimation. Which chemical substance do not undergo sublimation? Now, most of the time we are not familiar with all the chemicals, but if you will see the topic 2.3 of sublimation, you'll get the idea that they have mentioned some solid here. For example, ammonium chloride, iodine, naphthalene, and benzoic acid. So we can guess that naphthalene is present in that solid that can sublime. Iodine can also sublime, which is written over here. Ammonium chloride can also sublime, which is mentioned here. So there is only one option. We will use the rejection approach. So rejection approach theory says that will nullify or neglect all the answers that are not suitable. So these three answers are not suitable. So only one answer is suitable, and that is KMnO4. Okay. Now, if the temperature of the if absolute temperature of gas is doubled and the pressure is reduced to 1/2, the volume of the gas will be. So in this question, this is MCQs number 4 in chapter 3. It's very important MCQs. So let's solve it. We know general gas equation PV is equals to nRT. Now we can say that what is the volume? Okay, we're not writing V here, V1 here right now. Let me just rearrange the value nRT divided by V. So divided by P. So these are the values. Now we have volume 1. Let's say this is the gas 1, or initially the state if the absolute temperature of gas is doubled. So first of all, I have gas 1 with temperature 1 and pressure 1. Why I'm saying temperature 1 and pressure 1? Because N is constant, number of moles are constant, definitely. And the general gas constant R is also a constant. So we have same number of moles and R values. T1 and P1 is actually going to change. So they are saying that if absolute temperature of the gas is doubled, Like if we are doubling the gas, it means T2, like final temperature, will be the double of the initial temperature. And the pressure is reduced to one half. So if we want to know the P2, we'll half it, half P1. That's the simplest way to write the equation, to manage this equation or to put the values in this equation. Now you'll see that by doing this, we will now put the values in V2, what will be the new volume. So we can write the new volume as NR T2 divided by P2. Now T2 is 2T1 and P2 is equal to 1 by 2 P1. So we'll just put the values here. P2 is equals to NR. T2 is actually equals to 2T1. So we'll write here 2T1 divided by the P2 is actually equals to 1 by 2 P1. So we are getting a value which is dividing over here. The divisible and divisible is actually going upward, like we'll multiply it. So V2 is equals to 2 NR T1 divided by P1. And if I will take this 2 as a common as well, so I can write here as 2 into 2. So V2 is equals to 4, and this whole factor is equals to V1. You can see it here. So V2 is equals to 4V1. So it will be increased 4 times. That's the right answer of this question. So we have some MCQs in board where we have to solve the MCQs. Now this is also the same MCQ, same type of MCQs in which we will solve it. But first of all, let's see. The density of the gas can be determined by formula. Now we'll use the formula PV is equals to nRT. Now, number of moles are actually equals to given mass divided by molecular mass. So we can put the value here. PV is equals to given mass divided by molecular mass into RT. Now I will just rearrange the values and you'll get the answer. It's a very simple way. I am just highlighting it with red color so that you may be able to understand. Okay, so I can say that PM. Now it is dividing here. So I will take it to the other side of equal and we will come here. So I can write it as M by V into R and T. Now M by V, mass per unit volume, is actually equals to density. So we can say now that the density of gas is equals to PM divided by RT. So here is the right option. We can see it here, this one. Now, the crystalline system in which all the axes and angles are unequal is a triclinic system. You can see table 4.7 in your book, and C answer is the right answer because no angle and no sides are equal. So C is the right answer. This is topic 4.6. You can go through the topic as well, and you can see study the triclinic system as well. Okay, so that's very simple. You just have to see in chapter number 4, topic 4.6. Okay, ice occupies more space than liquid. Definitely, it is due to hydrogen bonding. That is why ice flows over the surface of water. So you can see the 9% more space. Okay, so it's present in book line. It's mentioned over here. So you can simply see it. Okay, 9% more space. Okay, the limiting line of Balmer series lies in the region. First of all, you need to understand what is limiting line. Limiting line is any line in which the final orbit is an infinity orbit. So you can see the Balmer series lies in the region. This is also present in the book. The limiting line of Balmer series lies in UV region while other lines fall in visible region. Okay, that's a book line directly. So you can see it over here. Okay, so this one is topic number 5.5.6. Okay. In MCQs number 10, in sp2 hybridization, the hybrid orbitals are oriented at the angle of. That's a very simple thing. Like in sp2 hybridization, we have 120 degree of angle if we have no lone pair. Okay, so BF3 is the example, and you can see the angle 120 mentioned over here. Generally, it has the angle of 120 if there is no lone pair. If there is lone pair, for example, SO2, so the angle will be less than 120 if we have a lone pair in the molecule. So it is not discussed here. So the answer is 120 degrees. All right. A state function. Definitely, you're familiar with chapter 7, in which we know that a state function is the function in which we'll see the initial and final values only, the independent of the route followed or the path followed. So, a state function which describes together the internal energy and the product of pressure and volume. So, here you go. HE plus PV, so product of pressure and volume, is actually enthalpy. That's the right answer. You can see it over here as well. Okay. The 12th MCQ is about enthalpy change of reaction. Okay, enthalpy change for the reaction is CH4, we are using methane gas, and in the excess of oxygen, we are converting into carbon dioxide and water molecules. This enthalpy in which we are burning something, we are getting carbon dioxide, is known as combustion. You can see it over here as well. Okay, the amount of heat liberated is always exothermic. Remember, it is always exothermic. All right. In MCQs number 13, we have to find the Kc values or the units of Kcs. So H2 and I2 is 2Hi. When I will write the Kc value here, the products will be here like this. And the reactant will be in denominator, H2 and I2. Now, if we will see that we have equal number of moles in reactant and product, the line is mentioned in topic 8.1.2 that if the reaction has equal number of moles of reactant and product, then equilibrium constant has no units. So you can see the other example as well. This is the example of esterification, which is present in your book. So anything like we have equal number of moles in reactant and product. So mole per dm³ whole square divided by mole per dm³ into mole per dm³. So we can collectively say that all the units will be cancelled with each other. Okay, MCQ number 14 is about the passing of HCl gas from the saturated solution of sodium chloride. This is linked with common ion effect, and we know that in common ion effect, the presence of common ion suppresses the ionization. It is actually following the Lee-Chatelier principle. And according to Lee-Chatelier principle, if we'll increase the number of product, then the rate of reaction will be shifted towards the reactant. So when we add HCl or when we pass HCl from the solution of NaCl, there will be more products present and the rate of reaction will be shifted toward reactants. Okay. So the solubility of the compound will be decreased. Okay. So remember that when we pass HCl gas, we'll get sodium chloride precipitates. And this is also one of the industrial method to purify the sample of sodium chloride. And it is this topic is also present in the practical copy as well. Okay, the oxidation number of manganese is KMnO4. So we can write this KMnO4. That's very simple. Potassium belongs to alkali metals, so it always contains a positive 1 charge. And the oxide here is a normal oxide. So manganese is X and oxygen is -2, and we have 4 oxygens. The total charge on this KMnO4 is 0, so we can write it as 0. So 1 plus X -8 is equals to 0. X is equals to +7. Okay, this is the highest state of manganese, sorry. So the right answer is +7. Okay, the 16 MCQs is about the following cells is used to the extraction of sodium metal. Which one of the following cells? So Dawn cell is actually the cell in which we'll get liquid sodium metal by the electrolysis of molten sodium chloride. Remember, we are using molten sodium chloride here. So NaCl, sorry, I think that color is not visible. So NaCl, we use temperature up to 801 degrees Celsius, and then we'll get sodium ions and chloride ions liquid, and then we'll pass electricity and we'll get sodium metal and along with chlorine gas. So Dawn cell, diaphragm cell is used for the production of sodium hydroxide. A galvanic cell is any cell in which the spontaneous reactions can happen to give us electricity. It is a Dawn cell, which is a type of electrolytic cell. Okay. So extraction of sodium metal by electrolysis of fused sodium chloride is carried out in Dawn cell. It is written over here, so you can get the answer. The question 17 is about the catalyst, the substance which retard the reaction. Rate of reaction is called. So it is given over here. Anything that can retard the reaction is known as inhibitor or negative catalyst. Like it can affect the activity or it can decrease the rate of the chemical reaction. Okay. So that's it about for the 17 MCQs. I am Harun Iftikhar and I'm the lecturer in F.Sc College. Thank you so very much for your time and patience. Your errands, any error or omission is warm-heartedly welcome. Your suggestions will be very important in the improvement of this recording. Thank you so very much for listening me. Take care. Allah Hafiz. Bye-bye.